Alright. Example 4. How do we show this limit? Okay, so our goal, we want to show that the absolute, first of all, let's look at the problem. For the limit, show that the limit of the square root of x minus 1 as x approaches 5 is equal to 2. Okay, so our goal is to find a delta greater than 0 that works for epsilon is given here to be 1. For all x such that, okay, this inequality implies that f of x minus L in absolute value is less than epsilon, which our epsilon is 1. Okay, so let's go back to the first step. The first step says that we are to work on this inequality and find an interval AB that contains 5. Okay, so let's go ahead and work this inequality out. Right? Solution. Okay. Remember, if you want to go ahead and follow the steps in the previous slide. It says there that the first is to solve this inequality. Okay. Solve that inequality and then find an open interval that contains 5. So let's try doing that. Absolute value of the square root of x minus 1 minus L equal to 2. Okay, it's less than 1. Okay, so using our definition of absolute value less than a constant, this means that square root of x minus 1 minus 2 is between minus 1 and 1. Okay, add 2 throughout. 2, 2, 2. We'll have the square root of x minus 1 less than or is between 1 and 3. Okay, and then take the square of everything. We'll have x minus 1 between 1 and 9. Add 1 to everything. Plus 1 plus 1 plus 1. We have that x is between 2 and 10. This is our open interval, okay, that contains 5. So the next part of our problem now, see if we have another slide here, okay, right there. Okay, so notice that we have an open interval that contains 5. So let's go to the next slide. Right there. Okay, so it's like we're now going to get step 2 of the previous slide. And step 2 says find a delta greater than 0 that places that interval inside to the open interval to 10. Okay, so that's part 2. Go back. Remember, this is like part A. Okay, part B. X minus 5 is less than delta implies that x minus 5 is between minus delta and delta, or x is between 5 minus delta and 5 plus delta. Okay, so in the previous slide, what we found was that x is between, so from A, part A, working out that inequality, we discovered that x between 2 and 10 satisfies that epsilon inequality. So what we do here is just, what we're going to do is just match up these endpoints. Okay, so if 5 minus delta is equal to 2, okay, if 5 minus delta is equal to 2, then delta should be equal to 5 minus 2, so delta is equal to 3, right there. Okay, if on the other hand we do 5 plus delta is equal to 10, then our delta would be 10 minus 5. Delta here would be 5. Okay, so we pick the smaller between these two, and of course that means our choice of delta is equal to 3, because that will always take the minimum width centered around 5, and that's how we get our choice of delta. It has to be an open interval that is contained in this interval 2 to 10. Okay, so you have that open interval from 2 to 8, which is contained in this interval 2 to 10. So if our choice of delta is 3, then that guarantees that, okay, if x minus 5 is less than 3, then we are guaranteed that the square root of x minus 1 minus 2 is less than 1. Okay, and that proves that the limit of the square root of x minus 1 as x approaches 5 is equal to 2. Okay, so we can say therefore the limit of the square root of x minus 1 as x approaches 5 is indeed equal to 2. And this is just our graphical representation of our proof. So we created our epsilon given to be equal to 1. That's why we have this yellow horizontal strip. Okay, you have that yellow horizontal strip, and then we worked our way. That is how we gotten our open interval, is by working on that absolute value of x minus square root of x minus 1 minus 2 less than 1, and we obtained this open interval. Okay, and then after that we found our delta, which is the minimum of the distance centered around 5, that will assure us that the vertical strip right here would still be contained, would still be within the horizontal strip. In other words, this box right here is still contained in the horizontal strip. Here are some of the exercises for section 2.3 that you can try out. Okay, what you can do is just pause this video and then work out these problems. There. Finding deltas graphically. The first part, these exercises, you find the delta from step B, using step B. Okay, here you find the deltas graphically. Okay, here find the deltas algebraically using the steps that I gave in the slide.